Thank you. Good morning also. We have an important day ahead of us if you follow me all the way to the other university, because today we study two central aspects of cognitive linguistics, namely metaphor on the one hand and grammatical constructions on the other. And of course, that is sort of the heart and soul of cognitive linguistics, grammar and metaphor. And you've heard a lot about these topics if you came to the previous forums by Ron Langaker on grammar, and George Lakoff, of course, very famous for his work on conceptual metaphor theory, and Len Talmy, also notable for his work both on grammar and the psychological underpinnings of grammar, and mappings and metaphor. Things like fictive motion, for instance. I didn't bring that up, but I must bring it up. Fictive motion, that you, again, if you came to the forum in October, you certainly heard about fictive motion from Len Talmy, and we'll try and discuss that again, because there's an aspect in fictive motion of mapping and integration that's also very interesting, and that's been pointed out by my colleague Ed Hutchins. So let's get moving this morning, and let's start the lecture on metaphor. Now, we've already broached the topic of metaphor in previous lectures at various points. And if you look at the handout, there is a very short recapitulation starting on page 40 of your book, page 1 of the metaphor handout. There are a few reminders from lecture 2 about the interaction of conceptual blending and metaphor. And you might remember then from yesterday and Friday that one of the things, it's only on your handout, it's not on my slides. One of the things that we discussed in the 2 or 3 previous lectures was the lecture on conceptual integration and the lecture on emergent structure, was the fact that conceptual metaphor theory was too simple. It was on the right track. It was, breaking new ground, very important. So I'm not underrating metaphor theory at all. It's one of the very top, very important contributions, not only to linguistics, but to cognitive science in general. But we noted that the schema source to target projection was too simple because in many cases, and perhaps actually all cases of metaphor to some extent, there is not just projection from the source to the target, but there is actually development of novel emergent structure in what we've been calling a blended space, connecting, of course, to the rest of the network. So on page 40 of the handouts, you have the reminder of digging the grave example, which requires the blended space in addition to the 2 inputs. The 2 inputs are the sort of old source and target of standard metaphor theory, but you need the blended space in order to account for the novel emergent structure. The fact that when you dig graves, if you dig long enough, you end up dying in your own grave. That's not a feature of either one of the inputs, but it's a crucial feature in order to get this human scale that we've talked about many times, the human scale aspect of the blend, where instead of the diffuse input of making a lot of financial mistakes and you don't know what's happening and so on, you have this human scale idea of you dig a hole, and of course, if you dig a hole that's very deep, you end up in a very deep hole you cannot get out. And that hole becomes your grave, okay? So that's another input that I did not even explicitly put into the diagram, but that's another important input that explains the emergent structure that we get in the blended space and that accounts for the compression. In order to explain to somebody that they're making mistakes and that they're not even aware and that those mistakes are going to make them fail, you use this very powerful compression of digging themselves into a hole. But you make it even more powerful by making that hole a grave so that they know they will die in that grave. Okay, we had also noted, again on page 40, example 3, we had noted that you could have metaphorical counterfactuals. That was the example of Clinton and the Titanic. And you said, if Clinton were the Titanic, notice that has a counterfactual structure, but it's not building a counterfactual world where the person Clinton suddenly becomes a boat. That's not the idea. It's building a counterfactual that's metaphorical. It's building a blended space in which Clinton is linked to the Titanic and the iceberg is linked to everything, all the opposing forces that are trying to impeach Clinton and make him resign and make him leave the presidency. Okay? And in the blended space then, what was important, what I pointed out, was that in the blended space, you did not have the structure of the source domain Titanic iceberg where the Titanic sinks. You had a novel structure that was actually set up deliberately where the Titanic does not sink and the iceberg sinks. And that the whole point of that particular counterfactual metaphor is precisely to exploit the novel structure to highlight the strength of Clinton. Okay? So you cannot do these things with the simple source-target theory of standard metaphor theory. You need the addition of blended spaces. But now this morning, I'm going to talk about further complications, because it turns out that it's not enough to have just, let's say, one blended space. If you look in great detail at a given metaphor, you will find actually an even more elaborate structure with a succession of blends, blend after blend after blend, accounting for the total metaphor. And the example that I'm going to discuss with you this morning is the example of the metaphors for time. And those are well-known metaphors, okay? Talking of time in terms of space. So in simple standard metaphor theory, you have a source domain of space and it projects onto time. What we're going to see this morning is that the real picture is actually more elaborate. There's a lot more going on in that metaphor than the simple projection from space to time. Now, as we go along, let me issue a warning. You might say, well, isn't all this getting too abstract, for example, or too complex? And remember that, in fact, all of this is happening not in our conscious manipulation of words. It's happening in this unconscious backstage cognition, where the brain is capable, the brain of the young child, like the brain of the adult, is capable of doing amazingly complex, hidden, unconscious operations. So it's no surprise that in the construction of meaning, you would actually have a hidden structure that is more complex than what you experience consciously. Now, it's the role, of course, of the cognitive scientist, you and me. It's the role of cognitive scientists, cognitive linguists, to actually delve into the hidden structures, into the backstage cognition that we can't see. And one of the ways we do that is by interpreting linguistic data. And I had a very good question on the first day about what about the role of experiments here. And experiments can indeed complete the picture. So you can also do psychological experiment to corroborate, to confirm the backstage cognition that is going on. So let's see how that works. Let's start with a little bit of psychology and psychological experimentation. The first thing I want to note, this is a slide from one of my colleagues in the cognitive science department at UCSD, the University of California, San Diego. His name is Emo Todorov, and what he studies is locomotion, how people move their arms and legs and so on, and how you could build robots, for example, that could do the same thing. Now, it turns out that understanding locomotion is extremely hard, again, because there are very complex brain patterns, and there's a very complex muscular structure. We have thousands of muscles that we never think about, okay? And so when you try to simulate locomotion, both in terms of the brain and the muscles, you really have a very hard problem. Now, Todorov points out that the reason we have brains as organisms, we and lizards and mice and fish have brains because we move. The brain is crucial for moving. And there are other organisms that are equally complex. They have very complex genome structure, like trees, but they don't have brains because they don't need to move. So the need for a brain is tightly linked to the need for moving. And the reason I bring that up is because many of the fundamental metaphors are actually take as their source domain, they take motion in space. Motion in space for us is extremely crucial, extremely fundamental. Okay, so again, as you well know, time is often talked about using spatial words. So you can say Christmas is not far away, we're getting close to Christmas, motion towards a particular time, Christmas, time flies, and so on. There are just countless examples. It's not one isolated metaphor, it's a very coherent metaphorical system. And again, the importance of this was pointed out very, very vividly by Lakoff and Johnson in their book, Metaphors We Live By, and it gave rise to a fantastic amount of work on metaphor across the world. Metaphor viewed not as a literary phenomenon, not as a kind of special abnormal figure of speech, but rather metaphor viewed as a fundamental central aspect of linguistics. Okay, that was the Lakoff revolution, shifting the notion of metaphor from something exotic and literary and not central to something that is central for language and even more central, if you will, for thought, language reflecting thought, okay? So that's, again, what we know. Now, here's a diagram taken from another one of my colleagues, Rafael Núñez, who also studies time. And on that diagram, you see the source, the simple, so this is the sort of simple view of time, where the source-target correspondence. And so things like in front correspond to the future in many, many languages, and behind corresponds to the past, and where we are now corresponds to the present. So there's this systematic correspondence of past, present, future with in front, behind, and here. One of the very important pieces of work that Núñez has been working on, and he wrote an article with Yves Sweetser in the Journal of Cognitive Science on this. He studied the Aymara Indians in Chile. And in the language of the Aymara Indians, there is actually a different organization which is corroborated by gesture and by grammar, where the future tends to be behind and the past is in front. The possible motivation for that is something like this. The past is something that we know. So it's something seeing is knowing as a metaphor. And so the past is something that we can know, and therefore, metaphorically, The past is something that we can see, whereas the future is unknown to us. And so it's like things behind us, things we cannot see. So this is a different organization from, let's say, English, and a majority of languages tend to have the future in front, and this is presumably, again, linked more to the experiential schema that if I walk in the forward direction, and so things that happen to me will happen in front of me and not behind me. You can see that there is room for different kinds of correspondences and therefore different metaphorical systems. Now, it's also well known, and this was again pointed out in the early book, Metaphors We Live By, but it has been studied over and over again in many contexts. So it's well known that there are at least, in fact there are more than that, but there are at least two central metaphors for motion and time, one in which it is the ego meaning the person that is moving, and the times are stationary, so we move through time. We approach Christmas. We get closer to the end of the Beijing Forum lectures, okay? Things like that. This is ego moving in time, and time being a place that does not move. But there is another metaphor where the ego is stationary. The ego does not move, and the times are moving towards the ego, coming in front, and then they move behind. Okay? And of course, the kind of data, the kind of linguistic data that constitutes evidence for these metaphors are things like, for the ego moving, we're coming up on Christmas, and for the time moving, it's the end of the quarter is getting close. The end of the quarter is moving fast towards us. Or Christmas is coming up, where Christmas is moving. Okay, now psychologists ask the following question. They say, okay, there are these interesting metaphorical systems, but are they actually active in people's minds? Or are they only sort of dead metaphors that reflect the etymology of the words, that reflect a change, a historical linguistic change, so that words like, before, at one point could mean in front, and then later change the meaning to mean ordered in time in a certain way. And so the psychologist doing experiments will ask whether there is evidence that the metaphor is actually psychologically active when people use it, when people use the metaphor. And here's a very clever way of experimenting on this, and this has been done by Lera Boroditsky and a number of her colleagues, okay? But she has done maybe the most work on devising clever experiments. And some of these experiments use the following data here. You have the English sentence, Wednesday's meeting has been moved forward 2 days. And then you ask people, what day is it on? Now, given the two metaphorical systems that you have in English, this is actually an ambiguous temporal statement. There are two ways to understand moving forward, depending on whether you're using the ego-moving metaphor or using the time-moving metaphor. So if you're using the ego-moving metaphor, then the times are things like, here's Monday, here's Tuesday, here's Wednesday, Thursday, and Friday. So with the ego-moving metaphor, if the meeting has been moved forward, then forward is the direction in which ego moves. So 2 days from Wednesday to Friday will be the date of the meeting. The meeting will be on Friday, according to the ego-moving metaphor. On the other hand, in the time-moving metaphor, It's the days that are moving. So you have Monday and Tuesday and Wednesday and so on, and they're moving towards you. So you can think of the days as being bicycle runners, for example, okay? They're all in a row. Monday is in front. Monday comes first, and then Tuesday comes afterwards, and then Wednesday, and then Thursday, and then Friday. So with the time-moving metaphor, if you move Wednesday, the Wednesday meeting, if you move it forward, you move it to the front of the line of the bicycle runners, okay? So you move it to Monday. If you move it 2 days, you move it Tuesday is in front and then Monday is in front. So the answer using the time-moving metaphor is going to be Monday. In other words, there are two possible answers. If you're using one metaphor, the ego moving, you're going to answer Friday. If you happen to be using the time-moving metaphor, then you will answer Monday. Now notice that it's not the case that one of those is more correct than the other. They're equally correct. It's just an ambiguous statement. And people, when they answer the question, again, because all this is unconscious, they are not aware of which metaphor they're using. They don't stop and think, what metaphor am I going to use today? Will I use the time-moving metaphor or the ego-moving? No. They actually, because it's happening unconsciously, one of them will dominate over the other, and the answer will come to them automatically. They'll say Friday, or they'll say Monday. Now, what the psychologists did that was clever, they asked people this question, but putting them in different circumstances. So, in one case, they would have the person actually moving or imagining they're moving. I'll show you different scenarios. And if the person is in circumstances where they're moving, then there is a priming for the idea that ego moves. And sure enough, there is a statistically significant number of answers that is Friday, much greater than the Monday answers. So the fact that the person is moving or thinking of moving will actually favor the Friday answer. That proves, or at least strongly corroborates, the idea that in using the ego-moving metaphor, the person is also activating, in a real psychological sense, the person is activating the motion, the ego, their own motion, in order to think of the abstract question about time. On the other hand, if they place the person in a stationary position, sitting down, and they have objects moving towards the person, then the Monday answer dominates. Then the person tends to answer Monday. In other words, now you have a priming going in the other direction. The time moving is primed. Okay? So that's pretty interesting. And in fact, so here are some of the cases, okay? In this case, the subject is moving between two garbage cans or something, but in this other case, the subject is watching objects move. And here are the results. In the first case, you get about 73% Friday answers. In the other case, you get about 70% Monday answers. So there is a difference. Not 100%, but there's a significant effect. These are cases where they just imagine the motion and they get the same result with slightly weaker statistics. And here's some other examples that are really fun. You put people in a lunch line. They're just waiting for lunch. And you ask that same question. When is the meeting has been moved 2 days, the Wednesday meeting. When is the meeting? Is it Friday? Is it Monday? And people who are at the front of the lunch line, they favor the Friday answer. Why? Because they're almost, at the lunch table, so they really see themselves as moving. The poor people who are at the end of the line, and they feel themselves as not moving at all and lunch is very far, they tend to answer the Monday answer. Okay, so they are primed for the not moving, not ego moving, and the other ones are primed for ego moving. And they found the same results. So these are the results. And they found the same results when they went to airports or train stations. So they would go to the airport and they would interview passengers getting off the plane. And those passengers would give the Friday answer because those passengers were moving. And then they would interview people waiting for the passengers, people who had been waiting maybe 2 hours for somebody to arrive. And then those people would give the Monday answer because they were primed for not moving. Okay? So these are really, they're pretty amazing results, really. It shows that people have, depending on the context that's going on, they will have a stronger activation for themselves moving or from other things moving. But in addition, that stronger activation will then intervene, will play a role in the choice of the metaphor. So that is considered pretty strong evidence that the metaphor has psychological reality, not just a kind of linguistic remnant of something. So same thing in train stations, same result. Okay, so that's the first part. An obvious, very important role of motion in space in order to conceive of time, number one. And number two, the psychological reality tested by psychological experiments. Okay, number two. Now we come to complications. So this is now taken, what I'm going to talk about now, is taken from joint work by, again, myself and Mark Turner. And it's not in the book the way we think. It's in a more recent article that I put on the website. So if you want to read the complete article, it's a chapter, actually, in the book published by Ray Gibbs on metaphor. This book is just about to come out, okay? So a useful book for you to get hold of because it's going to have all the sort of major views on metaphor in that book. And Ray Gibbs, who himself is a psychologist who works on metaphor, I believe, is that the case, Thomas? I believe Ray Gibbs is maybe the very next speaker at the Beijing Forum. Okay, so that's Ray Gibbs, and maybe in October he'll be at the at this very same place. And what you will get from Ray Gibbs will be the point of view of psychologists. From people like me and Lakoff and Langaker, you're getting the point of view of linguists. But from Ray Gibbs, you'll get the point of view of psychologists. And I'm sure you'll get a lot of contributions from Ray Gibbs to show what kind of psychology experiments one can do in order to advance cognitive linguistics. So again, that is an important part of, again, the general answer to the excellent question that was raised in the first lecture about, well, what is the role of psychological experimentation? Okay, so in this article, it's called Rethinking Metaphor by Mark Turner and myself. What we do is we study in more detail the metaphor of time. And what we find is there's not just a simple idea of objects moving in a uniform way or ego moving in a uniform way through time, but rather there is a notion of fast or slow motion through time, or fast or slow motion of time itself. Okay, so what could that mean? Here are the examples. 3 hours went by, so you have the times going by, the hours going by. Notice that even though this is a spatial metaphor, you have units of time and they're moving, but you don't have the same kind of sentence. The star, the asterisk there, says that this is an ungrammatical sentence. The second one, you cannot say 3 feet went by and he was at the door. In other words, suppose the door is here, okay, and I'm moving towards the door. I cannot say 3 feet went by. But with the metaphorical use of time, suppose there is an event now and 3 hours later there's lunch, then I can say there are 3 hours separate me from lunch, and when I get to lunch I can say 3 hours went by. So the time system doesn't work exactly like the spatial system. Then if you look at the number 3, minutes are quick but hours are slow. Now, we all understand that, right? The minute goes by really fast. The hour takes longer. But in the metaphorical system, that should not be the case because the times all move at the same rate. In the simple standard metaphor of Lakoff and Johnson, all the times move at the same rate. It doesn't matter if it's a small minute or a big hour, they all move exactly at the same rate. And in fact, the minutes are contained in the hours, so the minutes have to move at the same rate as the hours, like people in a train, if you like. If the train moves at a certain speed, then everybody in the train is moving at the same speed. And yet, we say minutes are quick and hours are slow. So again, this is not accounted for by the standard metaphor. I'll skip some examples, but now look at number 5. Those 3 hours went by slowly for me, but quickly for him. Now, if the times are moving uniformly, how could the times move differently for me and for you? It's the same time. It's the same hours on the watch, okay? Again, not explained. This is not explained by standard metaphor theory. Same thing for these examples like 6 and 7. Now, things can be even more extreme. You can say time came to a halt. What could that possibly mean? In the standard metaphor theory, if time comes to a halt, you know, it's the end of the world, because normally time just keeps moving at the same rate all the time, so to speak. Okay? But in fact, we say time came to a halt. Time froze. When do we say that? We say that, for example, when there's something very difficult to do and that we want it to be over quickly, and in fact, it looks like time is not moving. So these are all subjective notions. We have subjective experience of time as moving faster or slower and at different speeds for different people. Okay? This is not, again, explained by the standard metaphor, which has all the times moving the same way for everybody. And then you've got examples like this. Sure, it's Friday afternoon, but Monday morning is already staring us in the face. That corresponds to a case, you know, this is the weekend, so it's Friday. Today is Sunday, so don't worry about that. But if you have a weekend, not like this weekend, but a normal weekend where Friday is the last day of work and Monday is the next day of work, then the problem for somebody on Friday is that they don't want to go back to work, but they can see that the weekend is going to feel very short. They're not going to have time to do everything they want and so on. And it's like Monday is already here. You know, how sad. You know, Monday is staring us in the face. So Monday feels very close because of the weekend. Whereas in the other direction, of course, if you're on, let's say, Wednesday, then Friday seems very far, not close, because you're waiting impatiently for the weekend, and so it seems far. Same thing for all of these examples, and you can have things like it will go by faster. You know, something painful is going on. Well, it'll go by faster if you don't think about it, or if you're asleep, of course. Okay, so all of this suggests a more complex organization of time than standard metaphor would suggest. So what is it that is actually going on? And I will give you an outline of the analysis that Turner and I proposed in order to account for what is actually a very wide range of facts. So here's what we do. We take, remember, in the same spirit as in the last, as on Saturday and Friday, of looking for inputs to various integrations. The first input that we take is the input of events, and we've talked before about just regular event structure. So human beings consciously divide the world up into events. I'm not trying here to find out what events really are, either metaphysically or neurobiologically. I'm just stopping at the level of the way that we consciously divide up the world. And we can say, well, this morning I had breakfast, and after breakfast I walked to the lecture hall, and then I listened to this long lecture. And so there are three, you've divided the morning into three events. There was breakfast, and then there was walking, and then there was the lecture. Okay. Of course, you can find sub-events within the big events, and on, and you can find overlapping events, all kinds of things. So that's how humans have memory. In order to be able to do this with events, they have to have memory, and in fact they have to share memory, because if we have breakfast together, we will remember breakfast as being the same event, even though each of us may have had different things to eat, of course, for breakfast. So it was a different event in one sense, but it was also the same event of having breakfast together. This lecture is the same event for all of us, but we are all experiencing the event in very different ways, obviously. I am experiencing it as, what should I say, what should I not say, are they listening, are they asleep, and so on. That's my experience of the lecture. Your experience of the lecture is, for some of you, how fascinating, how exciting, tremendous. For others, how boring, I hope this lecture is going to be over soon. So you can have, of course, different experiences of the lecture. I hope there are no people of the second category. I was just inventing that. Only people of the first category. So in any event, we understand event shape. So we take as an input the human psychological capacity to understand events, to have categories of events, and to remember events, of course. Okay? So that's the input E. I call that input E. Now, event spaces can include subjective experience of those events, as I just outlined. The lecture can be painful for one, pleasant for another. It is yet the same event. Now, here's another input. This input I call X, and this is the input of motion through space. So motion through space is also, of course, a series of events. For example, I stand still. That's one event. I stand still for, a certain amount of time. And then I start to walk, and that's another event. And then I fall down, and that's another event. All these, of course, are motion through space. Now, motion, so the input X here is the set of motion through space events. Notice that it is part of E. That is, the input E of all events contains, as a subgroup, it contains the events of moving through space. The events of moving through space are very directly accessible for us. They are human scale, precisely. They are events that we can see, we can experience them in our body, we can experience them in others. there has been a lot of talk recently in cognitive science about mirror neurons. Neurons that have been discovered in monkeys and that certainly exist in humans, probably even more. And these mirror neurons, mirror like the mirror that you look yourself in, the mirror neurons have the property of firing both when you're doing a certain action, grasping, and when you see somebody doing the same action of grasping. So they're sensitive to your own actions and to somebody else's actions. Similar actions, of course. Okay? So that means that we have a neural system that, among other things, is very sensitive to motion in space, both our own experienced embodied motion and the motion of others that we perceive, that we see, or that we feel. Now, that's, of course, totally in keeping with the comment by Todorov about trees don't have brains, and animals do have brains, because the brain, one of the specialties of the brain, is actually to control motion, and to imagine motion, to perceive motion, and to understand that the motion of another is the same as my motion. That makes the space of events X, which is a subgroup of E, the space of motion in physical space events. It's a very important subgroup for us. And what happens in the event structure blend is that we can match X to E. We can blend X with E. What does that mean, blending X with E? I'll come back to this. Let's see. Okay, I'll come back to the other part that's important, but blending X with E means taking all the events, E in general, all events, and matching them to events of motion in space. And then blending so that in the blend, every event, not just motion, but every event, like listening to the lecture or having breakfast, every event becomes motion through space because it's been blended with a motion through space event. Now, this is, of course, nothing else than the very, again, well-known event structure metaphor. This is a metaphor that was studied by Jane Espenson in Berkeley, and it is reported on and analyzed also in the work of Lakoff, in particular the book Philosophy in the Flesh, that I'm sure you know about. Okay? So there's a detailed analysis of the event structure metaphor. Now, the event structure metaphor is a blend because metaphors are often blends. So what it does is it blends the general space E of events with the special space X of motion events in space. Okay, so let's go back a little bit and see and talk about the properties of X as we experience them psychologically, the properties of motion through space. And here are two properties that are going to be important for understanding the metaphor. The first property is a very obvious one. If we travel from A to B, and then from B to C, we know that the event of traveling from A to B is over, is finished, before the event of traveling from A to C, the complete event. Okay. So if the path is a subpart of the complete journey, then we know that the event corresponding to that path is going to be also finished before the entire event. This is very common sense, right? But it's a key to mapping the spatial distances to the event of moving through those spatial distances. So that's point number one. Point number two is, again, if you travel from A to B and then from B to C, then AB is shorter than AC. No surprise, regardless of what path you choose. So this is a very general topological property of moving. Okay? A very simple one that we, find obvious. But now look at this. What about the notion of fast and slow? In English, we say that going from A to B is faster than going from A to C, even if our speed is actually the same. Now, so this is tricky. Suppose you're traveling exactly at the same speed, uniform speed. You go from A to B, and then from B to C. Okay. Now, A to B is a shorter distance than A to C, right? If you're traveling at uniform speed, you're not faster on the first part than on the whole part. You're exactly the same in terms of technical speed. But actually, that's not what the word fast means. The word fast says that A to B is faster. That is, it's faster to get to, let's say, the hotel next door. It's faster than to go to the other end of campus, even if you're going at the same speed. So what fast and slow in English are really singling out is not speed in the technical sense of, the speed of a bicycle or a car. What they're looking at is actually the distance covered. So fast and slow really refer to what distance you're covering. That's going to be important in what comes along later. So now we blend events in general with special events that are motion events. And this allows us to use spatial vocabulary. So we can say we can go through the lecture just like we can go through the park. We go through the park, that's real physical motion. But all of us are now going through this lecture. I'm moving a little bit, and you're moving almost not at all. But in the blend, we're all moving through the lecture event. Okay? So that's important thing. In the blend, we're now all moving through the lecture. In the blend, any event, because in the blend, everything is motion through space. So in the blend, any event, like the lecture or the breakfast or whatever, has a certain length. It has a certain distance corresponding to it. And it also has this notion of fast and slow. So you can say, the lecture yesterday was fast, but the lecture today is slow. You don't mean that they took a different amount of time. You could mean they both took, let's say, 1 hour maybe. But your feeling was that yesterday it went along, fast, and today maybe your feeling is it doesn't go along so fast, even though in fact we're covering exactly the same distance. Okay? So that's an important subjective feeling. But it may be fast for one of you and slow for another. So the feeling of speed depends on the person experiencing the event, even though the event is going by for all of us in the same way. We're not traveling in time, this is not science fiction, and so on. Okay, so this is the first step. We're able to build a blend EX. And now, this notion of fast and slow, it applies to ordinary motion. And this could be considered a case of metonymy, if you like, but more insightfully, it's a case where we transfer one aspect of motion to another aspect. So the motion always corresponds to the path. So we can now point to a road, and we can say that stretch of road is faster than the other stretch of road. We don't mean that it's longer, or we don't mean, of course, that the road itself is moving. No, the road is not moving. What we mean is that somebody who moves on that road, on the first stretch will move faster than on the other one. Why? Because maybe on one stretch of road is full of holes or something. Or maybe because one stretch of road is windy and the other one is straight, even though they have the same distance. Okay? So that we can apply the words fast and slow, not just to moving object, but to the corresponding non-moving paths that the object goes through. Okay. In the blended space, you go from A to B, and the event is going from A to B. But because this is motion through space, there are different roads to go from A to B in the blended space, of course. So one of you may choose a fast road, and another one may choose a slow road. And let's see if we have the diagram for that. Here's the diagram. So in the first one, you go from A to B and from B to C in a straight line. And that is a faster road and a faster event. And the second one, you zigzag A to B and B to C, and this is slower and longer, of course. It's a longer stretch of path. Now, the way the metaphorical blend is working is very interesting, because it takes the event itself, the shared event that we have together in the blended space, of course, in the blended space where every event is motion. The event that we share together is going from A to B. So here's the start of the lecture, here's the end of the lecture, and we all go from A to B. And in real time, the time of the watch, it takes the same real time for all of us to get from A to B. But in subjective time of how we feel, then some of us may take a straight path, and others, for the same event, may take a crooked path. And that corresponds to the idea that when you experience the event, you may, for example, be doing a lot of things at the same time. And another person may be doing nothing. And so there are all kinds of things that happen. You may have expectations. You may wish for the event to end, and therefore the road in the blended space, the path corresponding to the event, will seem like a long path. That's when you feel that the lecture is long or the event is long. Okay? So this is the crucial thing. Because we're now in a blend where everything is motion and space, we can look at the past and we can see that for the same event, AB, people can have different paths in the blended space, of course. And therefore, one of the paths may be long, the other short. One of the paths may be fast and the other slow. This explains the words we use in English, the fact that we can say this was a fast lecture, slow lecture, and so on. And it explains the fact that this can be different for different people because they can be using different psychological paths in order to experience the same event. Okay? So this is the dimension of subjective experience of time, which is here reflected as different kinds of paths to go from one point to the other point. Now comes another input. That's one that we mentioned yesterday when we talked about the emergent structure of time. And the emergent structure of time is the time of the clocks. And we remember yesterday we showed how there was this experience of days, and then there was a compression into the cyclic day that starts over and over again. And then there was a great blend with engineering devices, namely clocks and watch and sundials and clepsydras and so on. And that blend gave us the notion of timepiece. Now, the notion of timepiece depends not on subjective time, but on objective time. It depends on the fact that the mechanical device is operating in synchrony with all the other mechanical devices at the same rate, no matter what the individual feels. So the mechanical device has a single path to go through the event, whereas people have a lot of different paths. And so what we find here then is the notion of another input M, which is M is the notion of shared universal events. Now, this is something we take for granted, but it's actually a very interesting human conception. Once we have the clocks and watches that we showed yesterday, okay, we can then take the event of, let's say, the hand of the clock going from, from 10 to 11. We can take that event, and each one of us experiences that event. But it's a universal event because it's the same on the clocks for everybody because, again, of the engineering feat of being able to synchronize all the clocks. So instead of saying, oh, 1 hour on this clock, 1 hour on that clock, 1 hour on the other clock, we can just say 1 hour in general. We can compress, and this is a massive compression, we can compress all the watches and clocks into one single universal timepiece, as if there was only one timepiece. Of course, this could be, sometimes there is one timepiece that serves as a reference for everybody else. The Greenwich time used to be maybe the time on the clock Big Ben, okay, and that was a reference. Or now you have very complex atomic clocks that depend on the movement of atoms and maybe the decomposition of atoms or something, and they are considered the norm for everybody else's time. But what's important, we don't care about which one is the absolute reference. What we care about is that as human beings, we can compress them into the notion of the same hour for everybody. So now we have these events, the hour. These are invented human events, remember? They don't exist in the world until humans come along and build watches. And now we have the event of the hour 10 to 11 is shared by everybody. So this is a universal event that we all share. The lecture is an event that some of us share, all the ones here, but not everybody else in the world. But the hour 10 to 11 is shared by everybody in the world. So we've been able to create an event that everybody in the world shares. And so these universal events are crucial. This is the timepiece that we talked about yesterday. And the integration network then consists in, on the one hand, the conceptual, this is the conceptual cyclic day here, and this is, over here, this is the mechanical device that is linked to the cyclic day with rods that turn, and over here we end up with M, which is the space of universal events, where we have hours and seconds, the universal timepiece. Now, in order to have this, we have to have two very important things: the capacity of people in the world for compression, and of course the capacity for engineering these fabulous timekeeping devices, which again, I remind you, are in the Hall of the Clocks in the Forbidden City. So don't miss that if you haven't seen it yet. We then have one ideal timepiece, and we can now talk about, because the event, the hour is now an event that everybody shares, in the blend of EX, we can talk about going through the hour. Okay? Just like we go through the lecture, we go through the hour. So the hour has now become, in the blended space, it's become something that is spatial, that we can move through. In order to do that, you have to blend the, the space that we had before. This was the blend EX. Remember, events in general, events of motion through space. This gives us a blend where every event is motion in space. Now we blend that with M. This is the universal events, the hours, the seconds that everybody shares. And we get a new blend, EXM, where we now have all events can be compared to the universal events, That's why we can time any event. We can say this event, this lecture lasts 1 hour and a half. This motion that I'm doing with my fingers lasts, 1 second. And we can do that by virtue of this blend. We can now go through any of these spatial creations, the hours, the minutes, and so on. In the blended space, they become part of the physical space that we can move through or that can move towards us. So this is, incidentally, this is a spectacular construction of the human mind, but also of human culture. It's not constructed by the human mind in one single blend. It's constructed over a long cultural period where people devise different kinds of timepieces, different kinds of ways to ensure synchrony. And we end up today with something that we find completely obvious. We say, well, there is time out there in the universe, and we have instruments that measure time out there in the universe. That's not what's going on. We are the ones who invented time. Of course, you can then ask the real physics question: what is the human notion of time that I'm explaining here? How does that influence specific theories in physics? For example, Newton's theory or Einstein's theory, where time can vary depending on speed of motion. That's a very, very fancy kind of question. But it's important to realize that time, both in its event shape and also mechanical instantiation, is a fantastic invention of the human species. Okay, as a result then, every event now has, because of this superblend EXM, every event has a measure: hours, minutes, seconds. Not surprising to us, but if you think about it, children take a long time to learn this. It's not something obvious at all. It takes several years, and the children usually will not know it well until 6 or 7 years old at least, will not master this complex conceptual system of time with the clocks and the watches and the events in everyday life. So it's a non-trivial system. Later, as adults, we find it as obvious as the language we speak. But remember, the language we speak is very hard to learn. So same effect, same cause, same effect. Now, because, remember, there were several paths that we could go through, this means that we can go through the same universal event, the hour. Somebody can go through the hour faster than somebody else. And you can say, if I give the lecture and it lasts 2 hours, I can say, hey, I went through the first hour much more quickly than the second hour. And what I mean probably there is something like, oh, I covered more distance because I covered more topics. So more topics become more events become a longer distance. If I covered a longer distance in the first hour, then, since it was the same amount of time, I must have been going a lot faster, right? And that explains the subjective structure of these funny sentences. Okay, how am I doing for time? Mapping between the events and events in M. We have the blends here, and we have 2 ways of blending. One where we project from the universal events, and one where we project from the subjective events. Now, if we project from the subjective events, and I've called this E underline, E bar XM, because you project from E bar into the blend, then you can have things like, remember, visiting your parents goes faster for me than it does for you, or goes slower for me than it does for you. In that case, the same event has different speed, even though it has the same length, for the reasons we explained before, because of these different paths. On the other hand, if you project from M bar, then you project from the universal event. And then you can say, visiting your parents will take an hour. And take an hour, point. You know, not 2 hours for you and 1 hour for me. No, 1 hour. That's the universal event. Okay, and so this is the way the network looks at that point. And here's a funny little trick. Remember that in the original, in the simple metaphor theory, you had space was mapped directly onto time. Now, what we've shown with this network here, we've shown that motion in space and then space itself, the corresponding paths actually, could correspond to time, because this is, over here, this is the notion of objective and subjective time that we talked about. Now, we can reorient this very same schema. I drew it sort of in the order that it was composed, but I could just draw it with a different orientation, and then I would get this. This is the very same schema as this, but just, you know, with the lines in a different position. If I draw it like that, I find space x over here, and then I find, you know, these all these other blends, and then I finally find time as we conceive of time as hours, minutes, and so on. Time is at this end. So now you can see that in the complex network, we actually do have a mapping from space to time. So Lakoff and Johnson are right. There is a mapping from space to time. But that mapping is actually the result of the constitution of this complex network. And we need the rest of the network in order to account for all the differences between subjective and objective time that we talked about. Okay, now the next point is there is a dual to this network. This network that I showed you was an ego-moving network of ego moving through time, either subjectively fast or slowly. Of course, you can have the time-moving network, and in that case, they're called X prime and so on. And in that case, you have examples like the 2 hours went by painfully. The lecture went by painfully. It's the lecture now that's moving, or the 2 hours that are moving. So it's the dual of the other one. And the structure that we get is the same as the other one, but with different spaces now, because EX prime and X prime, because X prime is the space of objects moving, whereas X was a space of me, ego, moving through objects. So now, if we put all those together, well, let's see. Okay, well, this one has even more. But if we put some of, forget this, I'm going to add this in just a minute. But if we put the ego moving and the time moving together, we have this complex network. Now, in addition to that, we have to bring in memory. And this is another part of the network where we bring in another kind of metaphorical blend, which is that we conceive our memory as being organized spatially. And in the spatial organization of our memory, here's the kind of thing that happens. We have the years race past. The years go past very fast. And remember, like the older you are and the more you feel that how can the years go by so fast? If you're a young child, the years seem to go by very slowly. If you're an old man like me, the years seem to go by very fast. Okay. Now, what is happening here? Why do we say the years go by very fast? Well, in our memory, we have events, and we have time separating these events, measured in years, measured in hours, according to the other networks that I talked about before. So if you say something like, the years go by fast, it's because in terms of the universal event, it looks like there are many years, okay, maybe 20 years. But in your memory, there are events like 1980, or your wedding, my wedding, okay, feels like yesterday. It feels very, very close. And there are many other events that I've forgotten, but I remember my wedding really well, and it feels like it was a short time ago. So in the metaphorical system, my memory is also a physical space. And you look at the two events, my wedding and today, and you say, well, that's funny because I know in universal event terms, I know they're very far apart. If my wedding was even before 1980, so it's a longer time ago. But suppose your wedding was in 1980, okay, and you say, oh, 1980 feels like yesterday. Okay. So in your memory, 1980 is very close to 2008. But how can it be close? Because you know by universal events that it's really 28 years, so it's a long distance away. Well, therefore, if, in fact, it's a long distance away, but if it seems close in your memory, then it's because you must have traveled very fast. And this is true. Let me persuade you of this if I can, and this will be, we're almost getting to the end. So this is true in real motion through space. Suppose you're in a train, and suppose you're traveling between two cities, okay? Now, you travel in the train, let's say, from Beijing to Shanghai. Now, suppose it turns out here that you go to sleep and you wake up and you're already in Shanghai. And so, subjectively, it feels like this was a very short trip. But then people tell you, oh, there are, I don't know how many miles, but there are hundreds of miles between Beijing and Shanghai. Then the logic is, well, if there are so many, if it's such a long distance, but if it felt very short to me, then the train must have traveled very fast. And this is the same logic that we use in the metaphorical blend. We have the years 1980 and today seem very close to me, like Beijing and Shanghai, because it looks like the trip happened very fast. Therefore, like the train must have traveled very fast, the years here must have traveled very fast. So there are many interesting linguistic examples of counterfactuals and subjective time. You can say, where have all those years disappeared? In the objective universal space, they're all those years, 20 years. In your memory, it's like you remember 1980, and then the other years, you don't have much memory. So they must have disappeared. But in your memory, they've disappeared. But in reality, they haven't disappeared. So you ask the question, they must have disappeared because in my mind, 2008 and 1980 are now next to each other. So the other years, I know they were there. I've been told that, there were 28 years. So they must have disappeared somewhere. In other words, when you say that, when you say, where have all those years disappeared, you give primacy to your memory over objective time. You say, well, what's true for me is what's in my memory. Those other years are gone. So if those other years are gone, they must have disappeared someplace. So this is the network that you end up with. You can see how it's much more rich, it's much more involved than a simple space-to-time correspondence. You can also see that it is motivated. If you had just a space-to-time correspondence, you'd say, well, why should space correspond to time? Space is different from time. Why would we use a correspondence between space and time to conceive time? Well, here, of course, it makes a lot of sense because it's not really space in itself. It's motion through space here, but motion through space is a subset of ordered events. And ordered events are what gives us, humans, the actual understanding of time. So that's why the source domain, ultimately, what was called the source domain in standard metaphor theory, X, ends up giving us these very rich conceptions of time with subjective and memory and so on. And it's because it's a subset of the events. And it's a very important subset because we're human beings and we're not trees, and so we have brains that are extremely, extremely adapted to motion through space. And so the events of motion through space become a way for us to think of the more abstract events that we do not experience in the human scale way. So even though this looks like a more complex picture, it's actually, in a way, a much more motivated picture. It explains why we have all these correspondences. It also, of course, is a much more explanatory model because it explains all this other data about, you know, time freezes and time goes slowly and the lecture goes fast and so on, that the other theory cannot explain. So that's kind of the bottom line of this new way to view metaphor. I put at the end of the handout section, I put this section where you have a literary passage that uses other metaphors for time. I will not talk about it, but I encourage you to read it and to see that the additional metaphors that are brought in are actually further blends. So what happens in the literary text is that you use the architecture of the basic time metaphor network, and then you blend it further with other inputs that you have. For example, here you have motion of the autumn sunlight from one wall to another wall. Or you have, look at this example, perhaps the mass of the past gathered there is pulling time out of the future. You bring in another frame where you pull something out, but the future is where it is. You pull out of the future and it comes into, you know, the present. All of these are just using the basic architecture, but then they're adding more inputs. Inputs of pulling things out, inputs of sunlight moving, input of the years unreeling. Unreeling means like a fisherman where you have a fishing line and the reel is that thing that you turn, and the line, the fishing line, unreels. It expands. And you can see what a horrible thing it must be to grow older and find that ever-decreasing number of years hurrying you faster and faster toward your grave. So we're back to the grave, always back to the grave. The years, because the years move, and because they seem to move faster when you're old, and because the end point when you're old that seems too close is the grave, it looks like you bring in an additional input. Since the years are moving and you are moving, then the years are the thing carrying you and pushing you, and they're pushing you towards the grave. My God, how sad. Okay, so that's it. For what I've said here about time is true of metaphorical systems in general. You need to study not just the superficial mapping, but the underlying networks that really are responsible for these metaphors. So we can have a few questions maybe, and then we'll move through space to the other university.